Now next we'll try to understand the polynomials in one variable. Okay, so when we discussed about the polynomials, we understood that there are no conditions for the coefficient, there are no conditions for the variable, but there was condition for the exponent. Exponent must be a whole number. This is a condition for a polynomial. Now we are going to look at the polynomials in one variable. Okay, polynomials in one variable. So when we take this 4xy, how many variables are there? X is a variable and y is a variable, right? So this 4 is the coefficient. The power of x is 1, power of y is 1. So this is a polynomial because all the conditions satisfied. The power must be a whole number, and then you can have variable, okay, which is visible. If you are saying just 4, then also there is a variable x which is actually x raised to 0, and then this 4 become a constant polynomial. When we say 0, it's actually 0 is the coefficient into there is a variable x raised to 0. The variable is there, the power is there, which is a whole number, so this is there, variable is there, right? Now coefficient is there, but that is 0. You get 0, right? This is actually 0. This is a 0 polynomial. Now what do you mean by polynomial in one variable? Only condition is, let's take this x. We can say this is a polynomial in one variable, right? If you look here, this is 1 into x raised to 1. So why it is a polynomial? Because no condition in coefficient, so it can be 1 or it can be 0 or anything. Okay, so we are not bothered about coefficient. Look at the power. Power is a whole number, so this is a polynomial. Why we are saying one variable? Because only one variable, that is x. Now if I say 4xy, can it be a one variable polynomial? No, here two variables are there. Okay, so I hope you understood what you mean by one variable and two variable. So only two things that you need to be careful is the power should be a whole number. That means it should be 0, 1, 2, 3, etc. It cannot be like, you cannot get root x. You cannot say this is a polynomial. Root x or 4 root x, this is not a polynomial. Why? Because root x is x raised to 1 by 2. And 1 by 2 is not a whole number. So you should have one variable and you should have a power which is a whole number. This is the two condition which has to be satisfied for a one variable polynomial or a polynomial in one variable. Now if I give you 5x square minus 2x plus 5, okay, so I'm giving you a polynomial. You know the degree is 2, so this is a quadratic polynomial. We had this discussion anyway, so we are not looking at the degree now. We have a polynomial. Can we say this is a polynomial in one variable is the question? Yes, we can say, because you have one variable, that is x. So two things that you need to look here is whether the power is a whole number or not. Yes, the power is a whole number. And then whether the variable is only one or not. If only one variable, this is a polynomial in one variable. Now let's take one more example. X square plus root 3. Is it a polynomial in one variable? Yes, it is a polynomial in one variable because only one variable, that is x. Now what about this root 3? Root 3 is a constant. Okay, so for constant I am not bothered about whether the power is whole number or rational number or anything else, right? So root 3 is nothing but 3 raised to 1 by 2. But since this is a constant part, that is not a problem. So root 3 is actually root 3 into x raised to 0. That's what root 3. So if you look at the variable here, that is x. And power of variable here, that is 0. That is a whole number. So this root 3 is not a problem. This is actually a polynomial in one variable, and that is x. Now what about this 3 root t plus t root 2? Can it be a polynomial in one variable? See, if you observe here, t and t, you have only one variable here, but if you expand this, it's actually 3 into t raised to 1 by 2 plus t into root 2. So here the power is 1, but here the power is 1 by 2. I told you this is not possible because 1 by 2 is not a whole number. The power has to be a whole number. So this is not a polynomial in one variable, or this is not possible. Now if you take this part alone, then you can say only one variable, that is t, and the power is 1, and this root 2 is not a problem for you. So that is actually a polynomial in one variable. What about x plus 2 by x? Now what is the problem here? This is x raised to 1, no problem. But what is this? 2 into x raised to minus 1. So since this is minus 1, it's not a whole number, so you cannot say this is polynomial. Now one variable, that is true, one variable, but the power of the variable is minus 1. That's the problem here. Okay. Now what about x square plus y cube plus 20? So here you have no problem with the powers of the variable, but the problem is with the variable itself. You have two variables. So this can't be a polynomial in one variable. Now what do you mean by degree of polynomial? Degree of polynomial is basically the highest power in the polynomial, right? So if that is the case, what is the degree of this polynomial x square plus x plus 1? Degree is 2, right? This is the highest power. So what about degree of polynomial x raised to 5 minus x raised to 4 plus 3? The degree will be the highest power, so the degree is 5. Now what about 2 minus y square minus y cube plus 2y raised to 8? What is the degree? This is the highest power, so the degree is 8. Now what about just 2? If I am giving you 2, you can write as 2 into x raised to 0. So basically you have a variable x. If you want, you can write it as y also, 2 into y raised to 0 also, keeping y as the variable. But what is the power? Power is 0. So what is the degree? Degree is 0. So if you just have a constant part alone, or in case of a constant polynomial, you have degree 0. So the degree of a non-zero constant polynomial is always 0. Degree of a non-zero constant polynomial is 0. 7, the degree is 0 because 7 x raised to 0. What about 0 polynomial? That is 0. This is actually because 0 into x raised to 0. 0 polynomial is basically because the constant part is 0. The reason is the coefficient is 0. So it can be either 0 into x raised to 0, 0 into x raised to 1, 0 into x square, then also you get 0, 0 into x cube, then also you get 0. So can you tell me what is the degree of a 0 polynomial, which is also a constant polynomial? 0 polynomial is a special case of constant polynomial where the constant is 0. You cannot say because it can be x raised to 0, x1, x2, x3 or whatever it is. So basically the degree of 0 polynomial is not defined. So what we understood is basically the degree. So degree of any polynomial is actually the highest power in that polynomial. Okay, so highest power. So degree of any polynomial is the highest power of that polynomial. Now degree of a constant polynomial, it will be always 0. Okay, degree of a constant polynomial within the two categories there. Non-zero constant polynomial, then the degree is 0. If constant polynomial is 0, then the degree is not defined. Not defined. So I hope you understood the degree of polynomial. Now depending on the degree, you can name, right? You can name the polynomial. So if degree is 1, you have linear. If degree is 2, you have quadratic. If degree is 3, you have cubic polynomial. And we have already understood this, right? Degree of a linear polynomial, how the graph will look like a straight line. Quadratic, it look like a parabola, right? What about cubic polynomial? Look like this. So this is how the graphs look like in case of linear, quadratic and cubic. So linear, quadratic and cubic etc. we name based on the degree. Now based on number of terms also we named monomial, binomial, trinomial, polynomial etc. Okay, so I hope you understood degree of polynomial completely.